Welcome everyone to this continuation of the Laplace transformation classes. And in fact, exactly in the last class, we have discussed the Laplace transformation of the derivatives, and I have written the results. Okay, the equation number is 1 for the first derivative of Laplace transform, and the second one is for the second derivative. We are going to see how this property means Laplace transformation of the derivatives can be written in terms of Laplace transform of without derivative. You see this. Here there is no derivative, here there is a derivative, which means that Laplace transformation of the derivative can be rewritten in terms of Laplace transformation without derivative. So that is the property that you have, subject to some initial conditions that you have. So this equation itself can be used in order to find out the values of this Laplace transformation of some of the functions. And you will find that this method is really much better than directly doing the integration. Okay, we have done the direct evaluation of integration and got the answer, that's all fine. But now we will see how this is going to be powerful and we can get the answers elegantly. Okay, let us see how do you do that. Now everything is available, you put it in the equation number 1. So all these things what you have to do is put in equation number 1 here. Okay, so let us substitute. So let me therefore write down what is there. The first term is the Laplace transform of f prime of t. F prime of t is 0. So you write down this Laplace transform of 0. Then this equal to you write down. Then s times Laplace transform of f of t. Where is f of t? This one. 1 is there. Then minus f of 0 is there, which is 1 here. That's all. And you what about Laplace transform of 0? So Laplace transform of 0 means integral of, you know the definition, right? Integral of 0. So 0 into e to the power of minus st, all that way. So ultimately this integral of 0 will give you 0. Therefore left hand side is trivial. So we can therefore write down that that is 0 here. Then that will be equal to s into Laplace transform of 1 and minus 1. Now here you have to be careful that again don't substitute Laplace transform of 1 equal to 1 by s. Okay, you know the result, right? What is Laplace transform of 1? 1 by s is the value. Don't substitute that. If you substitute, then what is the point here? Okay, the question example is that find these values. Okay, you are already substituting 1 by s means you already know the result. So there is nothing to find. So the point is that okay, we have to behave or we have to act as if we do not know what is Laplace transform of 1, and I am trying to find out the value of Laplace transform of 1 because of this property. So I am now exploiting the differentiation property to find out Laplace transform of 1. That's an idea. Therefore you should not put the 1 by s here. That is the meaning. 1 by s, we do not know what's the value. That is what it means ultimately. And then now we can solve this equation. So 0 equal to this minus 1, and this clearly tells you that Laplace transform of 1 will be equal to 1 by s, right? So as you can see that this s, you can take this one that side and then rearrange, you will be getting 1 divided by s. So this is how you get the expression for the Laplace transformation rather than finding by any integration. So we have not done any improper integral, and we did not discuss anything about convergence, and directly we got the answer. So in that way this method appears to be a little more elegant than the actual original integration. So that is the point that I would like to demonstrate. So that is the power of using these two equations. And if this is the case, we can always you can use many of the equations to find. Maybe you can try it for e to the power of 80 by a similar method. You start with e to the power 80 here, then you ask the question what is this, and then rearrange and get the answer, and you already know the answer, 1 divided by s minus a. So these are the expressions that you will be getting. And finally maybe I will this one, let me solve this. So I will take this third example. So third example is similarly you have to consider the given function to be sine of at. Okay, sine of at, and then you have to once again think about whether to use 1 or 2. Okay, that's what you have to think, and then which means that I need f of 0, f of t is readily there, and I need an f prime of t, etc. So therefore what happens is because of this starting point, now we can find out f of 0. So f of 0 means put t equal to 0 here, so sine 0 I'll get a 0. So that is one thing. Not only that, you can also calculate f prime of t. So therefore I'll now try to find out f prime of t, which you can differentiate this. So a will be constant coming out, a times cos of at. Okay, so now fine, this looks fine, but however you have to think and then plan whether to use equation number 1 or equation number 2. Okay, now you imagine that I am going to substitute here into equation number 1. If you are going to substitute, what happens is that here you will be having sine at here, and in the case of the derivative I will be having cos at. So this fellow will be sine, that fellow will be cos, and f of 0 is 0. So what happens is that I do not know Laplace transform of sin t also, I do not know the Laplace transform of cos t also. Therefore on both sides I will be having unknown quantity, and therefore I will be unable to solve. Okay, just to remember once again, we know the formula for sin at and cos at, Laplace transform. You know the expression, right? A divided by a square plus a square. But remember, that formula you should not substitute here. That is not the point. We are not doing that. That expression is obtained by integration method, and forget about it. Now we are freshly starting and asking the question, what is the Laplace transform of sin at? We want to get exclusively from either 1 or 2. If you want, you can go to 3 also by putting third derivative. So the point I am trying to explain is that equation 1 is not sufficient to solve this equation, because here you have cos function, here you have sine function, and this one is constant gone, but I do not know both of them. So left hand side also I don't know, right hand side also no, I don't know, means you can't do anything. So therefore equation number 1 is not useful right now. So therefore what you do is you go to the second equation. If you go to the second equation, what happens is I need a second derivative here, and therefore what to do is you have to find out what is second derivative. So you differentiate this once again, I get minus a square sin at. Okay, so that way that is fine, and not only that, you need an f prime of 0. Okay, so f prime of 0, how do you get? From here do you want to get? No, that is not the method. From here only you have to get the answer, because I already told you that f prime of 0 is nothing but f prime of t. In that you substitute t equal to 0. So from here you cannot get. So therefore this is not the path to get the answer. From here now we can substitute that f prime of 0 equal to f prime of t. In that you substitute t equal to 0, and this is nothing but a cos t, and substitute 0 here, you get cos 0. Cos 0 is 1, so a into 1 is a. So now you have all the values 1, 2, 3, 4. All the 4 of them are available, and then you can now substitute. Now the advantage is that on the left side I will be having sine, on the right side I will be having sine. That's a constant, that's a constant. So I have two constants and I have only sine function. So that means I have one side all constants, and then I can take all the sine to the left side. So that means one side I know known quantity, left side unknown quantity. Therefore I can do the calculation, which is not possible in the case of the equation 1. So this also demonstrates that how to choose which of the differential equations you have to choose for a given problem. So you have to think and then choose accordingly. And now the things are clear, and we will now substitute here in this equation. So I will write down here Laplace transform of f double prime of t is here, you put that minus a square sin at equal to, so let me therefore write down this entire thing, s square Laplace transform of sin at, then minus s into f of 0 is 0, then minus f prime of 0 is a. So that's all about it. So you can take this sin 80 here and this sin 80 here, that is constant. So I can write down that this gives you minus is common, a square, this will come to the left side, and that's all. That is equal to, you get a minus a on the right side. Okay, so that gives you, but what is missing here? Yeah, after taking common, there is a sin 80 is there, right? I did not write sin 80. So Laplace transform of sin 80 equal to a. So that gives you Laplace transform of sin 80 will be equal to a by a square plus s square. So that is how it proceeds, and of course now you see that without performing any integration, without discussing anything about the convergence of the improper integral, we are able to get the answer. So that is the advantage. Only thing is that in case if you are carefully observing, you must be able to ask the question, in this method where is the region of convergence? Okay, how do you know whether the real part of the s should be greater than 0 or the real part of s should be greater than real part of a? How do you get it? So that is the question that you should your mind should ask, and then the answer is that we can get the answer using the idea of the exponential order. Okay, that is how you start the first class. The very important point is that the function should be of exponential order. So using that one line, okay, you have to get this region of convergence. This is a very important idea. So in the sense, maybe I will just explain in 1 minute, just for information, because I already explained in the first lecture. What do you mean by that is that if you are going to consider sin 80, if this sin 80 is there, how do I know whether this function is of exponential order or not? That's the question. If it is an exponential order function, then you have to find out what is the order. That order is what you have to write down, real part of is greater than order. That's all about it. That is what I told in the first lecture. Now the question is that how do I know whether sin of 80 is a function of exponential order? That's the question. So the answer is like this. Whether it is sin 80 or whether it is cos 80, irrespective of these kinds of sine and cos, even sine hyperbolic, cos hyperbolic, all these functions, in general, at least these two, at least for these two, these are nothing but these are functions which are like e to the power of I80, because you can write cos plus sine, cos theta plus I sin theta. Therefore, what happens is these things can be written like e to the power of I80. And then for the Laplace transformation, I am going to multiply by e to the power of minus st. That's what you are going to do. And then the idea here is that whether it is an exponential order or not, that's the question. The answer is yes, it is exponential order, because you are able to write like e to the power something. So e to the power something is written, that's fine. But this I is there in the picture, and this I, what happens is when you take the modulus of this one, it goes to 1. Therefore, even though you have written exponential, then this doesn't come into picture. That means this modulus becomes 1, and the modulus is nothing but e to the power of 0 into t, right? 0 into t, right? Modulus is 1. 1 is nothing but e to the power of 0 into t. This 0 is the order, because I told you in the very beginning, I told you that the modulus of the f of t should be less than or equal to m into e to the power of alpha t. This equation is what you should remember in the very beginning. Therefore, when you compare this, 0 into t is there, alpha into t is there, alpha is 0. That alpha is the value for the order. So therefore, sin 80, cos 80, they are exponential order functions with order 0. Because it is order 0, you have to say that real part of s is greater than this alpha is 0, that 0 you have to put here. So that is how the story goes. So you have to be careful, and this is all about understanding the basics, then you can do it. Every time you have to ask the question, how can you write e to the power 80? Here it is already e to the power, so there is nothing to write. E to the power 80 is already there, right? So what is so the question is that for this problem, e to the power at, how can you write it as e to the power? It is already e to the power only. So therefore, you compare this with m into e to the power of alpha t. If you compare, what happens? Alpha is a. Therefore, what you have to do, since alpha is a is there, real part of the s should be greater than real part of the a, because a is there here. So straight away you get the answer. And for this 1, what will you do? 1 is nothing but e to the power of 0 into t. Therefore, 0 is the value you have to put. So like that you have to do. For all the problems, you can easily find out what is the order by asking the question, how will you rewrite the given function like e to the power of something? And if you are able to write that, what is the alpha value? That is the question. You ask that question, then you can get the answer. So in that way, you have to get this region of convergence. And the way of getting this solution is going by a different way. So this is how different approaches are there. So only when you must be able to travel in any direction. If one road is blocked, you must know how to escape from the given place. So therefore, you should know the multiple paths of getting the answer. So that is the purpose. Rather than we are not interested to redo the problem and get the same answer again and again. That's not the aim. Okay. So by this way, we understood this, and we will meet in another class with a differential equation. Fine.